Hello everyone, welcome back to Course Edit. So today we are going to not doing any. Today we are not going to be doing any tutorial or question practice. It is going to be a fun session. So this fun session tells you what's the importance of your next course which is going to come on this channel, or what important thing is there which you have to take from your next course, I would say. So let's begin with the course. So we are going to not do any question practice. We are going to animate using this MatPlotLib. So let's first import some libraries which are NumPy as. So suppose if you're new to this Google Colab, then what you can do, so the link will be given in the description. What you can do, you can just click on the link. You'll be directed to this Colab notebook. First sign in, and after signing in, you don't have to run these cells directly. Press this animation using MatPlotLib section. So you'll be directed over here. Then you will have to write your code, which is going to be something like this: matplotlib.pyplot as plt. Then what you can do, you can import matplotlib.animation as animation. Then you can have your import matplotlib. Then you can import patches. So patches is used to like draw figures. So if you are familiar with your game development, then you should know that there are few sprites which we already set up using your sprite section from the animation part. So this is similar to game development. If you already know the game development, then it should be easy for you to understand. So these libraries will be using NumPy and Matplotlib and all. So let's go with this. Let's first draw a graph on which we can have our animation. So plt dot subplots, I would say. Then let's go with your size, or you can directly define size from 20 to 20. Minus 20, 20. So this will be your size. Sorry, not minus 20. 20, 20. This will be your size. Let's define the range now. So let's define our range for the axis. So we can set x limit. So basically this will be your limit set to your x-axis. So ax means axis, and set limit for x-axis, which will be your let's say we have from minus 10 to 10. Then we can set limit for y-axis, which will be, I think, from let's see. So according to our animation, we will just need 10 of those. So let's do this 0, 10. I think this should be okay with us. I mean, this should look as what we need. So I think this is very good. Yes. So let's try to run this, or we can just give some titles as well. Set y level and x level as your. Let's suppose we have this x, and then say we have your. Sorry, this was y level. Ax dot set x level. Let's say we have this as x and this as y. We can also set few other things such as title. So let's say this is your title, which is going to be moving car animation. Moving car animation using math equations. Using math equations. So these equations are like very helpful to us. So that's the reason we are going to study. That's the reason we are studying maths. So just like it is useful in creating game engines, it is also helpful in creating, your AI engines. So you should know that it will be helpful for you in the future if you study math right now. Then we also have with us font weight, which is equals to your bold. Let's say we can do it italic, or let's keep it bold only. Okay, so this is what it looks like. Let's enter and see what we are going to get. So till the time it's execute, let's see what numpy.end here in. Okay, numpy dot array doesn't have any attributes, set x limit. Okay. Well, actually, it's not like that, but okay. So I chose this wrong. So it should be figure size over here. So let's say we choose this to be 20,20. Now let's try that again. Name fixed size is not defined. Okay. This is your PLT, which was your pie plot. Then you have your subplots inside that, which is going to be your figure size 20,20. Okay, sorry. So it was supposed to be equal sign as well. Yes, so we finally got this moving car animation using maths equation and this complete graph over here. So let me just resize this. It looks just too big for now. Let's make this instead of going from 0 to 10, let's make it 6 or maybe 8. Let's keep it 6 only. This looks perfect now. Yes, so it looks like yes. So let's make it even smaller. Let's go with 0, 0.4. So we are finally getting some something that we need, I would say. Moving car animation using math equations, MatPlotLib, which is your title. Yes, so finally it looks good. Next we have to write few equations. So for a circle, you know what your equation is. Let's say we write wheel as your first circle. So before this, let's calculate that graph over here. So let's say we have your we want to draw a wheel. So obviously it will be an equation of a circle. So let's write that over here. Let's say x minus 1. Then we'll have a square. Then we'll have plus y minus 1 whole square. Y minus 1 whole square. Let's say equals to 1. So basically you have center at 1 comma 1 and you have your radius equals to 1 as well. So this is the equation for your circle. Let's try another circle at a distance of 4, I would say. So 1 minus 4. So plus y minus 1. Obviously you don't need to uplift the y until and unless you want to make the car rotate in a travel in a circle as well. So for now we are just making the car travel in a simple I would say line. So car will be moving from here to here and wheels will be rotating as well. So just wait and watch what I mean by that. This should be square. So we got two circles. So first is your this wheel and second is your this wheel. So let's try to type that as well. So wheel 1, let's say wheel 1 is equals to your let's say it is equals to your circle. So let me see what all I have plotted or what libraries we are using. Obviously animation is just for animation and patches is for drawing figures. So let's draw a figure as well. So let's go with patches. Well, you can also draw using this AX. Basically PyPlot also helps you in drawing figures, but there you will have to write equations in your I would say using theta and all. So let's well, actually it looks too big, so let's set this what do you say, aspect equals to the aspect of your x-axis. Set aspect let's say equal. So let's see if there is any change which we are going to see. Yes, so it looks perfect now. Then we can just take 10 over here. Yes, so it looks perfect. Then we have this wheel 1 equals to patches. Then afterwards we have your dot circle. So directly in patches, if you write something, then it won't show anything. And then you just have patches dot circle. Then you just write the equation inside this. So obviously you need a circle at this place, and obviously radii as 1. Then face color. So let's say the color you want is yellow. Let's see what color we are getting. Actually I'm kind of colorblind, so Not completely, but yes, I can't actually determine what color this is. So let's call this red only. So we have your red, and then we have and then we also have, okay, so equal sign over here, and then we have your edge color, which let's call this red as well. Then I have your line width. Let's say your line width is basically, let's call it 2 right now. So either you can write it completely in a single line, or we can just give it separate lines. Let's say from here we want a separate line, so we can just have this. So for the properties, I would recommend using separate lines. Then we have this wheel 2. Let's say obviously you'll have to use the same things, but your that would change. What do we say? This center would change. Sorry, not 4,1. It will be 0,4. And obviously this is your radius, which is 1, and then you have all this. Yes, so it looks fine right now. You can obviously change your center from here to here, but it will be like calculating too much for a simple thing. So let's keep this 0 only for now. So we have this, and obviously we are going to have your next things, which are going to be your line and all. So either we can just so let me first create it over here. So we have this wheel over here, 2 wheels. Then we can have a rectangle directly above that wheel. So let's draw that as well. So I would say y equals 2, and obviously we want some this limit to be there. So rectangular body above this circle would be like I would recommend using let's say 1 less than, I mean, I'm just trying, I don't know what it will give. 1 less than equals to your 4. Okay, so let's just do 4 plus 1. Yes, so we are going to have it from 4 to that place. So let's say we have this 0 to 4, and let's replace this with 0, and let's say this is just your x minus 4 whole square. So you have this, it gives perfect line over here. Then we can have your second line, which will be your y equals let's say 4. Yes, so we are getting this complete rectangle by this. Let's just copy paste this condition over here instead of writing it again and again. And we have your x equals let's say we want it to be let's say we want this over here. So I think it's 0 right now. X equals 0. Yes. So 0 less than equals to your sorry, not 0. 2 less than equals to your y. So you can clearly see that this 0 comes from here, and 2 and 4 comes from here only. So we have this, and next we can also put the second line, which will be your x equals to 4. Basically a line over here. Then you can just copy paste the same condition over here. Now it's time to put some variable over here. Let's say this will be like increasing with the variable and decreasing with the variable. So obviously it looks kind of not like a car. Let's say it's a monster truck. So yes. So we have your rectangle over here. So for rectangle, you can just use a car body. Car body equals to your patches dot rectangle, and you can just give all the coordinates which you need. So for rectangle, you have 4 coordinates. Let's say we have the first coordinate as okay. Since this was this, we need a monster truck. So yes. So let's say we want this to be 0,4. Sorry, whatever it was. Let's say 2, 0. under this 0 to 4. So basically we'll be needing something from this place to this place, and over here we have, so basically this is your y equals 2. So we're going from 0 to 4, right? Yes, so it looks good to me right now. And we are going from 0 to 4, so we'll be taking another one which is your like changes which we'll be making. So let's say we are making changes of 5, and then we want the width to change by 2. Basically x wants to be changed by 5, and then y wants to be changed by 2. Basically that plus 2 over there, so 2 and 2 4, and then 0 to 5 over here. So sorry, it wasn't 5, I think it was 4. Yes, so we need 4 over here. So yes, this looks perfect right now. And obviously we can just give the same conditions over here. So let's copy paste this, and we can just paste it over here. Obviously we are not going to get rid of every place, so let's do this, make it blue. Sorry, let's keep the wheels of the same wheel as the same color. So we have this blue, and then we can just give this blue only. Yes, so it looks perfect right now. So we now just need to patch this in our access. So let's say access.add-patch. We need wheel 1, wheel 2, and car body. Okay, so we'll just be doing this, and then wheel 1, sorry, wheel 1, then let's copy paste this, copy, and then paste. Then we have wheel 2, and then we have rectangle over here. So let's go with the rectangle. So it's finally it looks very good to me right now. So if you want some like this circle to move in a way, then we'll obviously have to implement few lines inside the circle. So let's implement that as well. Let's say we have y minus 1 equals to your let's say we have this tan, let's say we have this m over here. So why I'm taking tan m? Because let's say you take tan of something like 12, then it'll just go down over here, and you put some condition over here. Let's say we have x minus 1, it will be going over here at some place. Then let's say you want to pass this through the center. Sorry, it will be x minus 0, not x minus 1. So it's passing through center of this, because this condition of circle, which was like basically 1 end to second end, it basically satisfies this line. So we are getting a line which is the diameter of your circle. Let's say we also want to put some conditions that this line stays inside the circle. So we'll be just adding this over here. Okay, so this is the condition for your condition, I would say. And then we want this to be less than equals to 1. Basically, if it is equal to 1, then it becomes a point instead of becoming a complete line. So we need every point which is less than equals to 1. So basically their addition should be less than equals to 1 instead of being just a 1. So we got a line which is inside this, and by giving this a variable, we can just add a different line, which is your we can add 3 lines simultaneously. Let's say we have this 1, 2, and 3. So this is the profit which you are going to get for those stuff which you are creating. Obviously, if you take 1, 2, and 2.5, let's say we have 2.5, then it will lie somewhere in between. So the difference between the upper limit and the lower limit should be like divided by the complete things inside this. So basically the difference between each segment should be equal. If it is 1 and 2, then it should be 3 over here. This is basically for the linearity. So it will be linear across this. This arc will be linear throughout your circle for each of those wheel stands, I would say. And for the second equation, you already know what you have to do. Let's implement the same m over here, and let's copy paste this. The only things that need to be changed are your x minus 4 and then the condition over here that x minus 4 square should be something which is like this. What happened there? Use parenthesis around the argument of tan. Okay, sorry. So we had to use parenthesis for the argument of this m. Okay, so we got both the wheels. And obviously, if you want to make this rotate or work like a car, you have to implement a variable, let's say of, let's call it x. No, we can't call it x. Let's call it var equals 0. Variable of which will be your 0. And we can obviously should try using parentheses. Also, we can just take a single word variable, I would say. Basically, in this math, whatever, Desmos, we can just take your limits, sorry, a variable with a single digit. Or there might be some way. Let's try var inside of parenthesis. Okay, so it is still not giving me that. So we have this variable h. Let's say we have your minus 10 to 10. And steps are the steps are going to be your 0.01. So this looks good for over here. So let's implement everywhere what our h will be doing. So we have this h over here, x minus 4 minus h. Then we have h to 4 minus h. Sorry, 4 plus h. Sorry, h minus 4 over here. Minus 4. H plus 4 it will be. I don't know what I'm doing right now. Yes. So again it will be h to 4 plus h. So basically we just define the variables from h to 4h. I mean 4 plus h. And h will be varying, so it won't be any problem to us for us. And x equals to 4 plus h. And for the same thing has to be done over here. So x minus h over here. And we can just implement this over here as well. Minus h. Then we have your x minus 4 minus h. X minus 4 minus h. Yes, so let's play this. It looks completely like a car to me. Or at least I would say that it looks a bit like a car. Yes, so you can see that the application runs smoothly. So we need to implement all these variables h inside this function, which is your current whatever it is. So let's call the graph which we have. Well, actually we haven't added anything yet, so let's not call that right now. Let's try plt.show instead right now. plt.show. Okay, so we are having some problem. Oh, okay. So actually in Python we need to like do it like this. Basically there is a way. You can just provide brackets over there. But let's do it in a single line. So let's try this now. Okay. So what we are having is some problem over here. Oh, okay, I got it. So over here we just wrote everything in small. Let's try that in big letters. Okay, so the rectangle wasn't defined. Over here we can just write capital R. Sorry, not capital R. It should be car body instead. I didn't notice that we had this written as car body. Yes, so it looks Actually, it didn't draw anything, but yes, it looks good to me right now. Okay, so let's try this now on our so let's try next function, other functions which we are going to implement. So we have wheel1, wheel2, car body perfectly aligned. So next we need to have your let's say spokes1. So basically there are few lines which we need to draw. So those lines are going to be your lines which we are going to like for the wheel let's call them wheel stand. I mean wheel lines, let's call them wheel lines. So wheel1 lines equals your this. Let's say we want to have 3 lines, so we are going to pass a tuple, basically a function which will be giving us the tuple of those lines. So there we have this ax dot plot this and this, and then color equals to your dark gray, let's say dark gray. I hope the spelling is correct, or we can just take yellow. Let's go with this. Then LW equals to your let's say we have 1.5 over here. So let's say for the 0th index we have your we have for underscore in range 3. So we have this 3 over here. Yes, so it looks good now. So basically what we are doing is we are plotting this on the axis which has your line width as 1.5. Basically this line width can be written as LW if you don't know. So we have 1.5 as your line width, and this 0 is your basically okay, so why do I, yes, so it looks perfect now. So basically this 0 is just gives you that is a function for this for that for this to be at the 0th index. So basically it starts from the 0th index and then it goes from 1 and 2 as well. So that's what your wheel 2 lines does. Then we have your, then you can just copy paste this with a different function, I would say. So obviously we have this as well. So basically these two are going to be lines which we are going to implement plus basically along with this wheel 1 and wheel 2. So let's go with that. So let's define init function over here. Then we have your wheel 1 dot set center. Wheel 1 dot set center equals your set center equals to your this. Let's say we have from minus, sorry, we can just go with 0,0 for now. And obviously wheel 2 we have to set center over here. Wheel 2 dot set center at your basically we can take minus 10 over it. Basically minus 10 plus 1, basically minus 9. So we have this. And for second wheel we have your comma 0. Okay, so since 0 is over here, let's take 1 over here instead of taking directly just a single center. Basically it will just go below this because our circle is of radius 1, so we need to have something above 1, the center at least above this, or we can just take half as well for it to perfectly align with this line over here. Then we can have your let's say second wheel to be let's say this was minus 9, then we can go with minus 5 over here. Well, obviously we need a difference of 4, I think. Yes, so we need a difference of 4. Yes, so we need a, okay, wait, I did something wrong over here. So we need 4,1 over here, not sorry, I said wrong at that time. So basically we need 4,1 instead of taking 0,4. Obviously we need y-axis to be the same. Otherwise if we take 0,4, then it will be like above this. Your second circle would go above this. So we have this wheel 1, wheel 2. Next we can have, okay, so I gave some space over there. Let's call pass over there. Basically, I'm just using pass to differentiate for the next function. Basically, two functions will be visible if I use something like pass. Then we have this set xy. Set xy for your from this range to range. So minus 10 to 10. It looks good. Yes. So it looks good for this. The above range would be 10. For the car body, the y range has to be not 10. Basically, we can take 1 over here if we need, or let's say the range has to be. Let me just calculate. This was 2 above, and this was 2. So let's say 5 over here. Then we have your car body to go from go along with this. So we'll be taking like something like your basically it will be ranging from minus 9.5. Then we'll be ranging it from 4 times 2 plus 0, which is your the same stuff. So we have your this. Well, just let me calculate it. So let's just give any random number to it now. We'll just fix that later. Basically, either you can calculate that directly, or you can just do what I'm doing. So there was supposed to be two parentheses over here. Yes, so it's finally correct. So next we can have your update function for basically update function is basically what you are updating every frame. So that's not much of a problem, I would say. So this is what it looks like, and then just we have to do the final stuff for underscore, or you can say for line in your wheel. Let's say wheel line plus wheel wheel 1 line. Okay, so we have underscore over here, wheel 1 lines plus wheel 2 lines. Then what you can do, you can just line dot set data. Basically, set data is a function for setting the input which you are going to give to your frames. So set data is just your input for the frame. So we are just going to add this tuple over here. So these two look good. Yes. And then we can just return, now instead of pass, we can just return this. So let's remove the pass from here. Then we can return your wheel 1, comma wheel 2. Then we have your car body. So this is one of the tuple which will be given away, and this not a sport. Then we have wheel 1 line plus wheel 2 lines. Yes. So this is what we are returning for your init function. Then we have your update function over here. Update. Let's say we have frame over here. Then we can have h equals to your whatever it was. Let's see the range. Basically minus 10 to 10. That's not a problem to me at all. Minus 10 times. Let's give the range to 20. And then we have your 20 times frame. So basically frame is the frame which you need, I would say. Then by 100 looks good. Then we can go with wheel 1 dot set data, or we can set center over here. So I think we have already set the center over here. Then we can update the center with your h comma 1 over here. then wheel2 dot set center from let's say we needed this from h to 4 plus h. Yes, so h plus 4 comma 1. Sorry, it went outside. Yes, so this looks good again. So we have both the wheels set. Next we can just update the car function, car body. Car body equals to, let me just bring a pass function over. Car body. Then we can just set center. Instead of setting center, we can directly provide xy over here. So we have this x comma y. So basically the range for x, basically the needed x will be your on the LHS of this, and the needed y will be on the right hand side. So obviously we have your from where to where? We have it from 2 to 4, right? Wow, it just went somewhere. Okay, sorry. I opened the wrong tab. So it was supposed to go over here. Let's say if we have 2 comma 4 over here. Yes. Actually, so basically 4 is the upper limit for y, and I think it would be minus 1.4 to 4h. And not minus 1.4. I would go with yes, 0 looks good to me. So h comma 4 plus h, or we can just go with h comma 2. And over here also we can just go with 2 over here. Yes, over here we can just go with 2 instead of going so far. And we can go with let's say 4 over here. Yes, so it looks good now. Then we can have your h plus 4 comma 1 car body is from h comma 2 to that. Then we can just enumerate everything from m value and all. So let's give the value of your slope, which was supposed to be 1 minus h, 1 2 minus h, then 3 minus h. Then what you can do for I comma m in your this enumerate basically m vals. So basically you are just traveling inside your tuple. Then you have your dx, basically a small change to be this np dot cos of your m, I would say. Then we can have dy as sine. Obviously you know what this is doing, right? Basically you are conducting the small changes that we need for both the things. Basically first we'll be doing for line, then we'll be doing for wheels and all. So we have this np dot sine m, I would say. Then we have your x data, which was supposed to be h minus dx comma h minus dx comma h plus dx. Then we have your y data going from this let's say 1 minus dy to 1 plus dy. Then you have your wheels wheel 1 lines, then set data. Then we'll be doing the same for wheel 2 lines. So at that point we'll be just we'll be just adding 4 over here because we need the 4 for the second line. You can see from h to 4 plus h we have this. So that's not a problem at all. So let's go with that. Okay, so I was like 0. This was from h to 1, then 4 minus h to 1. So yes, it looks good right now. Basically from 0 to 1. Yes, h to 1. and then you have your h plus 4 to 1, h plus 4 to 1. Then you have your car body, which will be for from your let's say this basically h to 2 and then 4 plus h to 4, h to 2 and then 4, sorry, not 4 plus s to 4. Basically car body is going from basically we are just taking xy from the single place, which will be your from where we are drawing the rectangle. Basically it was 0 comma 2, so we are just adding 0 to 4 this over here, and we are just adding that second one from 2 over here. So yes, it looks good. 0 comma 2 instead of sorry, we are going with h plus 4 comma, so h plus h comma 2 instead of going with 0 comma 2. So yes, this looks good right now. So we have your h comma 2. Everything looks good right now. So we have wheel one lines dot set. Then we can have the next line which we want to set. Basically x data and y data. We'll just implement them. X data comma y data. Y data. Then we can just pass the same. Oh, sorry, we didn't do anything for this. For the second line, so we are just going to copy paste everything, and then we can just change it from here to plus 4 minus dx, then h plus 4 plus dx. Then we have your, so let me just put a bracket inside this so that it looks good, and we are able to differentiate everything when once we write the code. So we have h plus 4 and then v1 minus dy. So basically this remains the same. So yes, it looks good right now. And obviously I forgot one thing. Basically for every index we need that instead of going with every tuple. Yes, so finally it looks good. So we can just yes, so it looks good. So we can just return finally. We can return everything from wheel 1. Wheel 1, basically I'll be just pasting this over here. And instead of taking this bracket, we'll be just taking a normal bracket. Yes, so it looks good fine right now. Now we can just go with the animation function, animation. Sorry, let's give it a variable name, any, and we can just call animation dot func animation. Basically this is a function for your animation which is available inside your animation library of the MatPlotLib library. So basically animation, you can consider it as a class and this as a function, and then MatPlotLib as your library. Basically we can create everything on our own as well, but obviously we had this Matplotlib, so I didn't want to. Update, then you have your frames equals to 101. Let's go with this init function. So next time I think I'll be creating this any function of the library, at least which is useful to us. Then blit equals to your true. Then let's go with interval equals to 60. Sorry, 6000, not 60. Let's go with 6000 by what FPS do we need? I think I need 60 FPS. So let's go with 100 FPS, I would say. So interval should be like 6000 by 60. Let me just check what FPS I took. So we are doing frame by 100. So we'll be needing 60 seconds of animation, which will be your 6000 by 100. Basically, you can just write 60 over here instead of writing everything. Or we can just take 40 over here for a smaller animation time. So it actually looks good. Let's press shift enter. Yes, so we just need to write any over here, then it should. What? So everything is correct, I would say. Let's see why it is not getting printed over here. So sorry, we need any to be called first, then we can just call this plt.show. Okay, so we are still not getting any error. At least we got this, that there is no error in our that function, I would say. So let's see what we have missed. We have this plt.show any animation. So you can just wait for a second. I will be just debugging this and coming back to you. So we are already past 45 minutes. If we had time, I would have done this directly live over here. Or you can try this doing live. So let's try considering why we are not getting any library over here. Sorry, we are not getting any mapping. I would say the graph is not being shown with the animation. So usually this doesn't happen. We have this figure. Where's the figure? Yes, it is over here. I think it's over here. Yes, it is over here. Figure. Then we have the update function, which is over here. Then we have frames as 101. I don't know why we took frames as 101. Wow. Let's try taking frames from instead of 101, we can take 60 frames. Sorry, 600. So we have, okay, so we will need a bigger frame. Let's try this now. And obviously interval has to be depending on the frame. So let's say we have the 100 times 60. Let's say we have your 6,000. Okay, so it's 60,000. Then interval can be your 60 along with that. Sorry, 1000 by 60. Yes. So everything is fixed. We just need to run this right now. It's not running it over here. We can take another compiler, I would say. But let's try to run this on Google Colab only. So we can implement so let's fix few more things over here. We have this set over here instead of set data. So let's check everything one by one. So basically till this it's correct, and after this much we already checked. This should be correct, and this doesn't look bad at all. So we have your wheel1.set center over here. So basically this doesn't matter in it function. So we have just this update frame. So we have your wheel1 lines, which was supposed to be x.plot, and then all the colors and all. And then we had this width, line width as 1.5. Then we have the 0 to start from, then 4 underscore in range 3. Yes. So basically this is also correct, wheel line 1 and wheel line 2. So we are just left with this update function. So we are going from h equals minus 10 plus 20 times your okay, so this was supposed to be plus instead of multiply. Then we have your 20 times frame by 100. Then we have your wheel1 dot set center. Then we have h comma 1. Then we have h plus 4 comma 1. So this all looks correct. Then we have your h comma 2, which is also correct. Then we have 1 minus h, 2 minus h, 3 minus h. That is also correct. So the next thing we have is basically enumeration. So we are going through everything inside this. So let's change this over here as well. Let's try this now. Let's remove this start. MatPlotLib.animation.fun animation at this. I don't know why I'm getting this. Okay, so we are still not getting anything. which is actually frustrating, I would say. Okay, so we have this for loop, for loop, for loop, and then def function, and then we have your animation function. Let me just check if there is no line spacing. There's no wrong line spacing, I would say. Yes, so line spaces are correct. For in function this, we have all this. Next we have your, I don't know what's wrong. Let's set this to false instead of setting this to true. False. Okay. So let's remove this init function as well. Let's see if that's not a problem. Okay, so that is not a problem at all. So we have this init function. So we have this. I hope this is correct. Init function equals to your init interval equals to your whatever it is. Then it should show with the plt.show, and we are not getting anything for some reason. Okay, so plt.show, we have this. Just give me a few more seconds. I'll definitely be able to run this. So let's try dot close instead of dot show, and then we just pass figure over here. A warning warn. What does the warning, by the way? Like this until you are. Okay, so we also need animation dot save over here. Okay. So instead of doing this, we can just export everything as this HTML video file. So let's try doing that as well. Let's say we have your from IPython dot display. Let's say we have this. Then we can have your import HTML. Then we can have, okay, so let's call this outside this function. From this we have this. Then we can just do HTML, and then we can call for your any.to, basically to HTML. Let's say we want HTML5 video. HTML5 video. Yes, it looks perfect right now. Let's try this as well. Basically, we are just converting this animation to directly HTML5 video. If that works, then also it's fine, but we will have to fix this as well. So let's see first what is going to happen, or what's happening. So let's try running this over here. Let's see if actually it's taking lots of time. So let's just wait for a few more seconds or minutes, I would say. Okay, so it is still converting that. So let's try this over here. So let's give the same thing. So obviously it's taking few time. So once it's executed, I will show it to you without changing anything. So I'll be just pausing this screen recording and then we'll meet once it gets executed. So actually it's taking lots of time. So let's try doing few other things as well. Let's say we can import MatPlotLib RC. Basically from MatPlotLib we can import RC dot RC as RC. Okay, so it's a function, not sorry, it's not a library. So we can just import from MatPlotLib, import RC. We'll have this function right now. Then what you can do, we can just create a different cell over here. Then we can just call for RC. Then we will have your animation, animation which has to be rendered. Then HTML. We can just give this as JS HTML, basically JavaScript HTML. So we have this. So let's try it over here. So let's pause this. It's actually taking a lots of time, so I actually don't want you to like waste much of your time. So we have this closed figure. Now we can just call any over here, and it's still not giving anything. So I'll just pause and quickly fix this so that once you are able to run this, you will be able to get the output instantly. Okay, so actually there was some problem, which was your init function as you saw earlier. So if it doesn't execute in 1 minute, then we'll be what's this? So let's remove this completely. Let's try any over here. Basically plt.show. So basically I tried reloading the page, which just helped me to fix anything which was missing. So basically at that time, okay, so let's do this only. So basically there was a problem with the reload function. I just had to refresh the page. And obviously we are still not getting any correct output right now. So we'll be just doing that again. So instead of doing it over here, I'll be just opening few other compilers. So let's say MatPlotLib online compilers. MatPlotLib online compiler. Let's go with onecompiler.com. And then we can just paste everything over here. Let's remove this. There, I don't think we need that. Then we can just Control V. And then we can try this. Complete over here. Then let's go over here. And let's try doing that again. So the animation doesn't work at all. So let's try fixing that over there. So next we have this complete function we need, and then we can just have your init function equals to your init. So we have this. And then we have all the other. Okay, so we need instead of capital F, we need a small f. Oh, sorry. And we can just go with plt.show. So let's try running this over here. Okay, so we are getting this same wrong thing, so we are getting a lot of lag right now. So let's try changing few things, which will be your, I think, few of the code which will be changing. So let me try that. So we have it over here. Then we can just go with your both the strokes if they are working or not. So we have wheel to lines, which is your this, and then wheel to line is basically the same as your wheel one line. The only difference is we have to add them at the next, add them for the next circle. And we have all this minus 9. Let's say we have this. Let's say we have this one. We have this as one as well. Instead of just going with 20 size, let's go with 12 and 16 over here. Let's try running this now. Okay, so one is actually working, but the lines are not rotating along with, or maybe they are rotating. Okay, so they are actually rotating. Yes, so they are rotating, but this doesn't have a line yet. Let's see where we left that. Okay, so instead of doing it wheel two lines, I just, when I copied and pasted over here from here to here, we just didn't change it from wheel 1 to wheel 2. Yes, so you can see finally it's getting animated. Let's try the same thing in your this Google Collab. So it won't work, I think, because for some reason it is just not showing it correctly. As you can again see, it is showing just this animation. Instead of showing the animation, it is just showing what is there. So it's not useful at all. So I'll be just leaving the code as it is. And I'll be just pasting a section over here that you can have. So instead of pasting it over here, we can just paste it directly below this. So, or we can just write this over here. Run this in any other MatPlotLib online compilers. I recommend using one compiler for MatPlotLib. Yes, so you have this. Basically it was, so let's remove this one. So we have this onecompiler.com. You can go over there. Let's remove this one compiler. Yes, so it's finally there. So you can just use this onecompiler.com and then you can just compile the code, which will just run your complete car animation, whichever you need. So run this and you get simple and easy car animation. As you can see, you have this complete car animation over there. So thank you everyone. Thank you for joining. Let's meet on Thursday. So basically on Thursday, we are going to have another question practice session. So after that, we can just continue with our data science session. So thank you everyone. Thank you for joining. Let's meet on Thursday and Sundays. And after 1 month, you'll again have a fun session. So thanks for joining. Take care.